So hello everyone. So today we are going to discuss about the Schmitt trigger circuit. This is basically the application of op-amp in positive feedback. So we know the op-amp is working on the three type of or two type of feedback: positive feedback and negative feedback. And without this, op-amp can also work as a open loop circuit. In this case, the two output possible plus Vsat or minus Vsat. In this case, the output will be finite value, and for the positive feedback, the output have two possibility, either it will be plus Vsat or minus Vsat. So Schmitt trigger basically the application of the op amp which uses is positive feedback. Okay, now we will discuss how to analyze a circuit which have positive feedback and how to find its transfer characteristic. Okay, now let's take a circuit, a simple circuit. Suppose this resistor is of 5k, and from the output we feedback the input to the non-inverting terminal of the op amp. Suppose this resistor is of 10k and the op amp is biased to voltage of plus 15 volt to minus 15 volt. Now as you can see, the op amp is in positive feedback. Why? Because there is only one feedback which is coming from the output of the op amp to the non-inverting terminal. Suppose if there are two feedback, one is coming to the positive terminal of the op amp or non-inverting terminal of the op amp, and other is coming to the inverting terminal of the op amp, then you have to check which one is dominant. So this one is basically a simple positive feedback circuit. You can always look in this way. Suppose you break the loop here and increase the voltage. If you increase the voltage here, this increase will come back here and this will increase its output. So you can see that for the increasing input here, we also getting increasing output. So this is nothing but a positive feedback circuit. So as it is a positive feedback circuit, I told earlier that the output here will be either plus Vsat or minus Vsat. So there is a two possibility of the output, that is plus minus 15 volt. Now let's solve the circuit. Suppose my output is plus 15 volt. So my output is, if is plus 15 volt, then V positive will be how much? 15 into 5 by 15, 5 volt, and V negative will be how much? 0 volt. Now to get or to change the output from a plus 15 volt to minus 15 volt, we have to make V minus greater than V plus, right? If the inverting terminal input is greater than the non-inverting terminal, then we get minus Vsat, right? This is the property of a simple comparator circuit using op amp. Now, sorry, I made a mistake. I did not connect any input here. Let's connect the input here. Okay, so this will be V negative will be V in, otherwise the circuit will be of no use. Okay, so V in must be greater than 5 volt to change the output from plus 15 to minus 15 volt. Okay, and in the similar way, suppose V output is minus 15 volt, then V positive will be how much? Minus 15 into 5 by 15, so minus 5 volt, and V negative will be V in. So to change the output from plus 15 to minus, from minus 15 volt to plus 15 volt, we have to make V plus greater than V minus. So V plus is how much? Minus 5 volt greater than V in. So V in must be less than minus 5 volt to change the output from minus 15 to plus 15 volt. Okay, now let's draw the transfer characteristic here. This is my V in and this is my V out. So output stays at 15 volt, but when it input changes greater than 5 volt, then the output become minus 15 volt. Okay, so the output is plus 15 volt. When the input greater than 5 volt, output switches from plus 15 to minus 15 volt, and this point is 5 volt. And in the other case, the output is minus 15 volt, and when the input is greater than minus 5 volt, then the output change to plus 15 volt. I draw it with a different color. Okay, okay, it become, now the output will become plus 15 volt from this point, and this will continue. So this is the transfer characteristic, okay, of a Schmitt trigger. So this is the flow of the output with respect to the input, and for the first case the arrow will be in this direction. Okay, I hope it is clear now.